Hi friends, you're welcome to the Nerd Lab. Today we're going to make a project on preamplifiers. So preamplifier is the basics of audio amplifier system. If you're going to design a sound system of any type, home theater, event amplifiers, slaves, engines, mixers, you name it, you are going to start from a preamplifier. So that's why this project is going to start from a preamplifier. So this project is the first in the stages of the sound system we're going to cover, so you can reach out for the other videos that I'm going to talk about, the other configurations equally that we're going to have. So without wasting time, follow me, let's start. So without wasting time, we are going to start from a preamplifier, specifically using the JRC 4558 IC. So there's a reason I made this 4558 IC a favorite, because it has lots of features that surpasses other preamplifier ICs. The preamplifier IC is also similar to many other ICs out there, and you're also likely to find different versions of JRC 4558. So they basically work the same way if they have the same part number. So what matters is the feature and the function. Alright, so the JRC 4558 is similar to UC741 IC, except for the fact that it doesn't have one redundant pin in the output, and then the pin arrangements are actually different. But basically, the purpose, the function of the block diagram in them are similar to each other. They also have similar operating voltage, they have similar protective features and all that. But then I prefer this 4558 to many other ICs, to be honest with you, and I've been using this IC for the past 7 years. Yes, I started using it when I was able to clone one circuit from a mixer. I was able to tear down one mixer, and then I extracted the circuit diagram from there. I extracted for equalizer, for preamplifier, threshold amps, and all this other input configurations. And honestly, I've been impressed, and I'm still impressed till now, and I want to show you all that, so you can follow me step by step in the tutorial to see how I actually design all this. And So this is the circuit diagram for the 4558 preamp IC. So this IC has a dual operational amplifier, and then you refer to the data sheet that was shown. You'll see the internal block diagram, how it was configured. But basically it contains two operational amplifiers, and with the two operational amplifiers you can get to design a dual preamplifier that you can use for your audio system, boost your audio system. Actually, there are a couple of things other things you can do with this 4558 IC. And disclaimer, I would also like to tell you that this circuit, I've been using it for up to 7 years now. I extracted it from one professional audio mixer, and I made it my favorite because of the performance. It is just very excellent, very clean sound output. It features lots of things that made me prefer it to lots of other ICs. And I can tell you that of all the preamplifier ICs in town, this JRC 4558, to me, it comes first, because it does just basically everything I want to do as far as sound system is concerned. So you can use it for, apart from the preamp, you can use it to design audio equalizer. You can use it to design passive filter circuits. You can use it to design low pass, high pass, band stop, you name it. So if you like me to share a very legitimate circuit of that, you do let me know in the comment below. Alright, so moving on, I made it a favorite and I've been using it since then. So this is the kind of circuit diagram you're likely not to find anywhere else, because most of the professional circuits keep their things private. But then I cloned it and I realized it worked well. It has extremely reliable protection system. I wish you short circuit to ground, short circuit to power, short circuit to input. Everything is just very, very, very active, and as a result, it's a very, very good circuit for a novice, someone who, or maybe a situation where you are trying to assemble circuits locally and those things that are prone to errors. This IC can withstand it. Alright, so let's move to the explanation. So this is pin 1. Oops, my pen refused to write. Alright, let's pick another one. This is the pin 1, and this dot doesn't actually mean it is pin 1. So you're likely to always see this dot on ICs. It doesn't mean that is the pin 1. It just means that's where the counting of the IC starts from, and then it goes all the way like this and then to this point. So this is pin 8. So starting from pin 1 is the output for the first channel. Pin 2 is the inverting input for the first channel in the operational amplifier. So this is the inverting input. Pin 3 is the non-inverting input, and pin 4 is the negative power supply for the IC. I told you it's originally designed to be split. You can also make it a single power, which I will explain in my other video. So pin 5 is the non-inverting input for the second channel. Pin 6 is the inverting input for the second channel. Pin 7 is the output for the second channel, and pin 8 is the positive power supply. So here how it works. Now, the inverting inputs are both grounded, while the non-inverting input is fed with the audio source. So you set the gain from the inverting input with the output. So there's no need to stress yourself about
thinking deeply on how this works, I will just try to explain it as simple as possible. So anyone at all can use it, but if you feel there is a need for further explanation, you can do let me know. So I will just tell you simply that this controls the level of input to a certain extent, and as a result, it clips noise. So the lower it gets in the value here, the more it is less responsive to any other noise generally in the circuit. And the more the value here, the less it responds to the noise. So it's like vice versa. You increase the value, you're likely to have more noise. You reduce the value, then you're likely to have no noise. But the more you reduce the value, when it gets to a certain extent, any less than 5 kilo ohms, you start to lose quality input. So the volume starts to drop. When this resistance gets to 0, then it's no longer sensitive to output. Now this is the opposite. It's not just like the opposite like that, but then it works just like the opposite. This clips off ripples in the input. So this is used to set the gain, and basically all these things have calculation, but just like I said, I'm going to make it very simple enough. So this value here, just like I said that the resistor is the gain, when you increase the value, the amplification increases, so you have a louder output. When you reduce the value, the amplification reduces, you have lower volume. So it's basically just like how this works, except on the contrary. So the more value here, the more the volume, and vice versa. So there's a certain level it gets to and it starts to distort. For instance, when you use anything within the range of 1 mega ohm down to 300 kilo ohms, you're likely to have fuzzy sound, distorted sound. So anything within, since it's a preamplifier, it doesn't have enough energy to work as a power amp anyways. It's okay to just keep it from 100k below down to 10k. So any lower than 10k, you will lost quality sound output. I mean amplified sound output. So this capacitor is a decoupling cap, and depending on the resistance that it's going to collide with on the output, this capacitor is here to compensate for that, separating the output channel from the IC itself. It further protects the IC, and it also polarizes the output. So the same thing applies here. So the configuration in the first circuit is just the same as the second circuit. You can see that the same values are used, the same configuration, the same topology. So as the same goes here, the same goes there. It's just that there are two of them inside a single chip. So you have that at the back of our mind. Now the input here is fed with the audio source, either from the phone, from the computer, anywhere you feel like the sound should come from. And it has operating voltage ranging from positive 5.5 to up to 18 volts. So you have positive and negative 12 volts as typical operating voltage. Alright, so I will lay an emphasis on this a little bit. The input that you can, the value of this capacitor also is also a decoupling cap, and additionally it controls the frequency that is fed into the IC. So the higher this value, the lower frequency capacity you're likely to get. So this capacitor allows the level of frequency input, the range of frequency input. So when the value rises, you're likely to have a wider range of frequency response, and as a result, you're also likely to have a wider range of when a range increases, a lot of features also come with it, including noise, including distortion. And when you reduce the value, you shrink the range. And at this point, it responds to just the higher frequency. So for instance, when you have from this 4.7 microfarad and it's dropped to, let's say, 100 nanofarad or 104 capacitor is used here, you're likely to start losing quality base. And this is very good because that's how this circuit is now generating the capacity to be used as equalizers, to be used as passive filters, so you can tune it generally. It's general purpose operation amplifier to design a configuration of your choice, either low pass, high pass, band stop, equalizer, you name it, it will do it. Another thing I didn't add here is that you should add a limiting resistor, but since the sound input is a low power anyways, you could eliminate it if you want. And it is just good if it's there. A limiting resistor from the range of 10 ohms to 22k is okay here that I didn't add. Actually, it will still work without the resistor. So in summary, I'm going to break down the basic features of this IC, and it's written below here. So we have the output power up to 650 milliwatts at 10% distortion. So when this percentage increases, the power increases, but it now comes with distortion. And when this percent reduces, the power reduces and it further gets rid of distortion. So with this, you can decide what you actually want by designing the IC. So you have maximum power supply up to positive and negative 18 volts, excuse me, a total of 36 volts. A maximum power supply down to positive and negative 5.5 volts, the total of 11 volts. So it has excellent crosstalk separation up to 97% accuracy. Well, honestly, I'll be true with you, I don't know how I actually derived at this 97% accuracy, but I do know that the crosstalk, so a crosstalk is the sound here jumping to the sound on the other side. That is a crosstalk. So for instance, when you only feed a sound into the first channel and there is no sound on the second channel, but the speaker is connected and the input is not having sound and the speaker is also connected here, the probability of you hearing a sound on the other side is what is referred to as crosstalk. And this IC has a very high capacity, to a point that at maximum volume output, you're likely to hear almost nothing on the other side, which is very good. If you're going to design an excellent stereo system, surround system, a crosstalk is going to be a look-at option. It has a very low noise and a low distortion, and just like I said initially, it has continuous short circuit protection. So basically, this is how the JRC 4558 IC works, and just like I said, it is very interesting. For further explanation, you can refer to the circuit diagram or just let me know down in the comment. Thank you guys. Have a nice day.
Alright, if you like this video, give this video a thumbs up, subscribe to my channel, like, share, and make sure you ding that bell so you keep updated for notifications. If you have questions regarding the video, you can just place it in the comment below and I'll be right there to give you an answer. And additionally, I want you to wait for lots of other circuits that I'm going to post regarding